From the studios of Postscript Media and Canary Media.
Mateo Jaramillo is the co-founder and CEO of the long-duration storage company Form Energy. Form has around 500 employees in California, Massachusetts, and Pennsylvania. Mateo spent the last 2 decades building battery storage companies, with home base being California. But he just moved from Silicon Valley to the Rust Belt, and it's a sign of a new era for storage.
And I was in San Francisco until last week, and now I live in Pittsburgh. And today I am talking to you from 84, Pennsylvania.
So 84 is the name of the community?
84 is the name of the town, spelled out, 84. And actually, Form has our facility here for manufacturing, and the address is 4284 Drive, 84, Pennsylvania.
That feels purposeful.
It does. There's some divine plan here.
Mateo's been working at the forefront of storage since the early 2000s. He got his start installing distributed lead-acid batteries in commercial locations for demand reduction. The technology was lacking, but he saw how valuable batteries could be for the grid in those early days. And then in 2009, he was hired by Tesla to build the company's powertrain business. And a few years later, he built Tesla's stationary lithium-ion storage division from the ground up. Today, Mateo's team is engineering very large batteries capable of storing 100 hours of electricity.
So these are individual cells, so the equivalent of what you would hold in your hand with a AA battery or even a lithium-ion battery, for us is about a meter tall. It's about 2/3 of a meter wide and about 10 centimeters deep. And so it's a very large thing.
And building many of those very large things requires a very large industrial site, which is why Form is constructing a manufacturing plant 30 miles west of Pittsburgh at a shuttered steel production facility in Weirton, West Virginia.
At its peak, it was a site that produced many millions of tons of steel for the United States. In fact, I think during the World War II, it was the highest volume steel producing site in the country and employed about 14,000 people at its peak. It closed down in the early 2000s, and it has lain fallow since then, really.
The location sits at the intersection of major highways, rail lines, and waterways. And it's also at the intersection of the old energy economy and the new energy economy.
We've broken ground. We're laying the foundation now. Building's getting tilted up over the rest of this year. And that is where we will produce our iron air batteries at volume.
Yeah, so what on earth does an energy storage company need with an old steel mill and the infrastructure surrounding it?
Well, we are making a type of battery which is based on iron and air. So we are reversibly rusting the iron as the electrochemical process inside of the battery, which stores and gives off the electricity that we need. It also means that we're moving a lot of iron in and very heavy things out. And so you think about sort of the core infrastructure that's needed to do that, and it maps very nicely over basically the steel infrastructure of the country. So along the freshwater system of the United States. And so we're reutilizing a lot of the core infrastructure there, rail lines on top of that as well. And part of the infrastructure is, of course, the human capital infrastructure and just the people that sort of know how to make things in heavy industrial environments. It's fantastic to be able to tap into the mindsets that have been around for generations here in the region.
America is working to build back its industrial capacity, hopefully with a lot of clean energy. Armed with lessons from the past and a lot more government support, companies are planning $70 billion in new factories for electric cars, solar and wind components, and batteries, including very large batteries like the ones that Form is making.
So this is infrastructure after all, whether it's highways or it's military or it's power infrastructure. So seeing what the government is doing today, it is quite broad-based, and there's a lot of things that are happening.
This is The Carbon Copy. I'm Stephen Lacey. This week, I talked with Mateo Jaramillo about Form Energy's transition from an R&D and engineering company to a high-volume manufacturer. Is it a sign of what's to come for the U.S. industrial base? This podcast is brought to you by Core Power, an American manufacturer of battery cells for electric vehicles and stationary storage. Core Power founder and CEO Lindsay Gorel is a former executive in the mining industry, and he's leveraging that experience to build a new battery supply chain in the U.S.
Early on, I fully understood how reliant the United States was on parts of the world for the supply of these critical products needed to develop the green economy. My goal has always been to bring lithium battery manufacturing to the United States.
Stay with us to the end of the show. We'll have an interview with Lindsay about how America can slash its dependence on imported critical minerals and batteries. The Carbon Copy is supported by Fish Tank PR. In this turbulent and exciting energy transition, your approach to communicating with journalists, investors, and customers must evolve. Whether you need to position yourself as a thought leader in between project announcements or translate complex ideas and technologies into tangible, compelling content, Fish Tank can help. To learn more about Fish Tank's approach, visit Fish Tank PR. That's FISCH Tank PR. And if you're looking for your next role in PR or media relations, check out Fish Tank's open job listings. The Carbon Copy is brought to you by Savant. No home can be truly smart without smart power. Savant Power Systems let you monitor, store, and control your home's energy, putting the power to live comfortably and sustainably in your hands. The award-winning Savant app tracks real-time energy production to enable maximum efficiency during blackouts and peak energy pricing periods. The Savant Power System. Focus your energy. Learn more at savant.com, SAVANT, savant.com.
I'm Charles Dance, your narrator for Hindsight, a dramatized podcast from Al Jazeera. In this season, we hear from some of history's most notable women. An unconventional and extraordinary artist.
Me? I am Frida Kahlo.
A communist revolutionary.
Everyone in China knew my face.
You've heard of them. Now it's time you hear from them. Hindsight. Listen wherever you get your podcasts.
In late June, President Biden was in Chicago outlining his economic theory, and he mentioned a certain company building a certain factory in West Virginia.
Weirton, West Virginia, where a steel mill closed in the beginning of this century. It had thousands of good-paying jobs that were lost. But today, with the help of the Inflation Reduction Act, a new plant's being built, building iron-air batteries, which are going to help store energy. And it's being built on the same exact site, bringing back 750 good-paying jobs, bringing back a sense of pride and hope for the future for all the people of Weirton and surrounding areas. That's Bidenomics.
Form has also brought in the enthusiastic support of West Virginia Senator Joe Manchin, and the company has raised nearly $1 billion from investors who are eager to back a company with the potential to change the market for batteries. And I wanted to catch up with Mateo as his company takes the leap into an industrial growth phase. Form has 5 co-founders. They've all worked in storage for a long time, and they all came together around the idea that the current technology paradigm is not sufficient for fully decarbonizing the grid.
We saw what happened with lithium ion. We saw the progress that it has made, and will continue to make. And yet we saw a very large opportunity still in the market, and that was to address something that lithium ion just was not addressing, cannot address because of its costs.
That something is longer duration. Now, there are grid-scale lithium-ion batteries that can discharge tens of megawatts for 8 hours, but those are rare, and adding more hours can add prohibitive cost to a project. And on a grid that is now driven by weather as much as anything else, we need to start building storage projects that account for multi-day dips in renewable energy production, not just hours.
That's what renewable power is weather-driven electric generation. And there are multiple days of intermittencies associated with any of the types of those kinds of generation, wind, water, or solar. And so solving those becomes a key challenge for getting to a very deeply decarbonized electric system.
You did it. You described it without saying the wind isn't always blowing and the sun isn't always shining.
I know, it's shocking, right? I didn't even use that German word that people sometimes use. So that's really what put us in the space to identify that kind of battery or kind of energy storage that would work. And that allowed us to really understand that the characteristics of what iron air could be as a battery would solve that problem.
So what exactly is an iron air battery? How do you get electrons from rust?
It's a great question, primarily because it's one that people naturally want to ask because we know a lot about iron. You know, everybody knows the iron rusts, right? Humans have known this for a very long time. You know, you could probably rename the Iron Age the Rust Age because if you know anything about iron, you know that it rusts in the presence of water or oxygen and some sort of electrolyte. And so it's been a long line of human learning around iron and what it does. And when iron is rusting, essentially what it's doing is giving up an electron. It's taking on oxygen and giving up an electron. Now, most of those electrons, of course, in rusting iron around the world they're given up for free, and they never come back. But what is possible to do in the right set of conditions is to have that reaction happen in a very controlled way and to reverse that reaction. So you start with a metallic iron anode, which is submersed in a very basic electrolyte. So there's salts in the electrolyte, and there are hydroxides in the electrolyte. And on discharge, what happens is that iron takes on one of the hydroxides. So it goes from pure metallic iron, Fe, to FeOH. And that is the charge carrier for us. It's not iron moving around as an ion, like a lithium ion would, but rather it's a hydroxide ion that is moving around and shuttling the charge there. And so that hydroxide goes onto the iron, and you have a larger molecule there. And that reaction is happening on the surface of the battery. But we have a very porous anode, so that surface area is more than just sort of what you would see from the outside, right? And that's why we don't get sort of that flaky rusting phenomenon that most people experience as rusting, right? Sort of, you rub something and the rust comes off. For us, that is a reaction that's happening on a lot of surface area throughout the porous anode itself. And then on charge, what we do is we essentially evolve oxygen out of the air cathode. So on discharge, we're breathing in oxygen. That oxygen is creating the hydroxide. That's what's rusting it. And then we reverse that. We breathe out the oxygen on charge. And that hydroxide is coming off of the iron. So we're returning the rusted iron anode back to its metallic state.
So I listened to an interview you gave recently with Akshat Rathi of Bloomberg, and you said it's easy to build a terrible iron air battery. It's harder to make that chemistry perform at the highest level. So what's the difference between a bad iron air battery and a commercially viable one?
The difference is around efficiency, and it's around manufacturability. In other words, can you make this device be a reliable, as highly efficient device as you possibly can make it, and low cost as you possibly can make it, and so that's the main challenge, right? How do you actually engineer something to perform the way that we need it to be engineered, as opposed to just sort of letting the reaction happen the way that it naturally, is happening around us all the time, but very inefficiently and not very cost effectively, that kind of thing. Iron wants to rust. And so on Earth, essentially, harnessing that in the right way is the challenging part. And that's what requires a lot of innovation and fantastic engineering.
And that's what I want to talk about a lot in this interview is the manufacturing component and what you need to do to scale as you build this new factory. So you're working toward building these batteries at a very large scale. And the factory underway in West Virginia will cost $750 million to build. What are the technical challenges in that scale, and what will that leap in scale do to your costs? Yeah, so that $750 million, in the end, that should deliver a factory that produces about 500 megawatts per year, which for us, these are 100-hour rated duration batteries. So it can provide its rated power for 100 hours, which means it's a 50 gigawatt hour per year manufacturing facility. So on par with all the other sort of lithium-ion battery factories that are getting built out there these days. But the capex is much lower to go do that. And what that will produce in the end is cells at that scale that I mentioned, sort of those meter scale cells, and we will produce hundreds of thousands of them. Getting to cost efficiency at scale means you have to be very good at making the same thing over and over and over again, or the right variants of that same thing. And so that's what we will do. That means that we can really dial in the process, and that we can really dial in the performance associated with the design that we have settled on so far. And you can really only do that in a really stable manufacturing environment. And so building a factory is sort of what you have to do. You can't have, we've learned this, we collectively in the power infrastructure industry have learned this over and over again. You can't really get cost efficiencies by having bespoke projects. They have to be fairly standardized in the factory environment, in the manufacturing environment, to really drive costs down. The chemistry is very, very low cost, so it's less than $1 per kilowatt hour for the active materials. The trick is building a device and delivering a system that keeps you as close to that entitled cost as possible. And for us, that will be
roughly $20 a kilowatt hour. We think we can go below that, but that's sort of the first target that we've got. And you can only do that if you have an engineered product made in a stable manufacturing environment and then delivered out to the projects and installed very, very easily. So that's what the manufacturing plant gets us. It gets us that environment to make that device to then deploy in a very seamless fashion out in the world. And the models for this, there are a lot of that. We're not breaking any new ground in doing it. As I mentioned, we've learned this in the infrastructure industry for a long time. But solar is probably the most prominent example of exactly that phenomenon of manufacturing scale and efficiency driving to low cost.
And this is what you did at Tesla as well. So you built the energy storage business at Tesla up from the ground up, and you oversaw this period of immense scale from product development to a commercial product. I'm just wondering, how do the technical challenges for this kind of battery, how are they different when you're developing a product like this at scale?
Well, looking back at the Tesla challenge, it feels quite straightforward now. We didn't have to worry about the chemistry. What was inside the can of the cell is that, lithium-ion cells at Tesla are sort of inside what are known as cans, the cylindrical cans. So what's inside the can at Tesla was fixed, and we didn't have to worry about that. It was great, well-performing, high-performing, and the work that had been done on the vehicle side also meant that essentially the module work, the collection of those cells, was also quite stable. We didn't have to worry about what was inside the modules. We took essentially automotive designed modules and put them into the right enclosures and put them into the right, control systems and, thermal systems and that kind of thing. But relatively speaking, it was a pretty short engineering putt, especially for a company like Tesla, which is phenomenal at engineering. That was such a treat to work with that team on that project, because we had all the expertise in-house to do all of the work, the mechanical work, the thermal work, the power electronics work, all of it. It was just amazing. It's sort of categorically a different challenge at Form, because we are developing the chemistry at the same time that we're developing all those other systems, the thermal management systems and the control systems and the mechanical systems that bring it all together. So it has been quite different. In fact, the first few years of Form's life were just spent on the electrochemistry, trying to really understand it and characterize it. And we didn't really tip into the engineering of the product until a couple of years ago. But we've been at this now for 6 years as a company. And so two very distinct phases, frankly. And we're tipping into the third very distinct phase. But we started as an R&D company. That's where we fleshed out the electrochemistry, the basics of it. We became an engineering company. We're now 500 strong engineering company, I would say, with a core of R&D in there. And we are becoming a manufacturing company. And that will be a new and distinct phase for us. It is already a new and distinct phase for us. But that challenge from the beginning was quite different from what we did at Tesla.
Yeah, I want to hear more about that. So you described these three phases: R&D, engineering to manufacturing. And your expectation when the company was founded that it would take a decade, perhaps more, to get to the manufacturing scale, and you are getting into that phase 6-7 years in. What in the engineering part accelerated that phase? Were there happy accidents? Was it just execution? Like, what happened there that made you accelerate beyond what you thought you'd be at?
Yeah, anytime you start down a path as unknown as the one that we started down, inevitably there are moments when you sort of turn over a card and it comes up your way or it doesn't. The universe works the way you hope it might, or it does not. And the few times that we've really truly had one of those binary moments, it's broken our way. And so, without getting into too many details there, we didn't really know if you could, like I said, we knew we could make a terrible iron air battery. The question is, could we make a good enough one at the cost points? And, there were a couple of moments there along the way where we just didn't know. And we had to marshal all the efforts of the company around a few really critical challenges that had to go get solved. And if they didn't get solved, we were either going to have to pivot or give all the money back or who knows what. But it was very clear that those were fundamental binary yes or no challenges. And when I say, the Billion team knocked those down, that's what they did. Now, they were extremely systematic about it, and they're just, phenomenally creative, intelligent people. So it's not as if it was just dumb luck that these things happened, but you just don't know, right? And you can have amazing, talented, creative intelligent, excellent people, and still the universe doesn't work the way you hope it does. So some of that, it all interacts off of it. We also benefited not just sort of things coming out the way that we wanted it to, but also we acquired a company early in pandemic, in fact, that had the technology that allowed us to really skip forward and accelerate the timeline, specifically for the air cathode. And so, this air cathode is a very delicate piece of technology. Imagine sort of a membrane, if you will, that allows oxygen to pass from the air and prevents liquid electrolyte from going back in the other direction, right? And holds that boundary layer successfully with current passing through it for 10 years. That's a tricky task for any piece of technology. And we acquired a company called Fluidic Energy, later Nant Energy, which was a zinc air company. They had already spent 10 years and $100 million on just that air cathode side of things. And they were a little early in the market for that particular technology, zinc air. But that specific component was and is amazing and allowed us to really incorporate that directly into the iron air chemistry and to really retire the risk associated with that particular line of development and really focus in on the iron side of things and the electrolyte and the way it all works together, but not have to worry too much about that particular component. And if we hadn't had that, maybe it takes us a few more years, frankly. But it all worked out, and we very happily have that as part of our technology stack now.
The Carbon Copy is supported by Fish Tank PR, a media relations and corporate comms agency dedicated to elevating the work of both early-stage and established companies across clean tech, including EV infrastructure, solar plus storage, grid edge tech, software, renewable energy project development, financing, and more. When you're looking for a PR firm, not many of them discuss transparently what drives results. Fish Tank has been in the clean tech industry for more than a decade and is able to use deep expertise to simplify messaging, collaborate effectively with clients, and consistently engage journalists. To learn more about Fish Tank's approach to clean tech and the services they offer, visit Fish Tank PR. That's FISCH Tank PR. And if you're looking for your next role, check out Fish Tank's job openings. The Carbon Copy is brought to you by Savant. With the launch of its intelligent power system, Savant is redefining what it means to own a truly smart home. The new Savant power system features the ability to monitor, store, and control electricity from the grid and solar to optimize everyday energy efficiency, offset peak utility costs, or maximize stored power to keep your family comfortable and safe during grid outages. The award-winning Savant app displays your energy production and consumption in real time and allows for easy-to-use control and hands-free automation. Plus, the system's scalable design means you can start small and expand as your needs change. When you're in control of your home's energy, the power to save on energy costs while protecting the environment, it's in your hands. The Savant Power System. Focus your energy. Learn more at savant.com, S-A-V-A-N-T, savant.com.
We live in a world where the news is at our fingertips, where we're one click or swipe away from the latest headlines. But how often do we stop swiping and scrolling and just listen? It's the difference between knowing what's in the headlines and understanding how it got there. I'm Malika Bilal, and this is The Take, Al Jazeera's daily news podcast, where we bring you the context and the people behind the global stories that matter. Subscribe wherever you listen to podcasts.
So where is long-duration storage headed? Form has inked deals with Georgia Power, Xcel Energy, and Great River Energy for projects that could replace coal or gas plants. Now, those projects have not been built yet. They're dependent on the build-out of manufacturing operations now underway. And to get those big customers, the company didn't just focus on the battery technology itself. Co-founder Marco Ferreira built an analytics tool for grid modeling, which helps prospective utility customers evaluate this new kind of infrastructure.
It was a very high-fidelity view of the grid as it actually operates. In other words, minute by minute, maybe hourly, hour by hour, sort of at the maximum, but definitely not using averages for like an average week, for an average season, for an average year, which is how a lot of modeling is done today to make plans about what the grid should look like in the future. And so if you look at the way that the utility industry does it and has done it for a very long time, it is that averaged approach that they take to try and forecast how to build this portfolio of assets to meet the growing demand that they're going to need. And if you average, no surprise, you sort of eliminate this understanding for these very non-standard types of events that are happening all the time now. And you also average away the variability and the reality, frankly, of how these weather-driven resources, wind, water, and solar, are actually operating, and then therefore the way that storage would operate on the grid. And so we built, Marco and his team built those models. These are what are known as essentially capacity expansion or maybe production cost modeling tools done properly, again, sort of sub-hourly level details to get to the right outcomes. You do have to model it correctly to understand the value of these new kinds of assets. And what we have found with these utility partners that we're working with now and others is they have these same tools, and when they use the tools in the way that we use the tools that we built, they get the same results. But if you don't do it, then you don't get the same results. And so having modeling done correctly is really fundamental to building the right kind of grid going forward. If you don't model it correctly, you're not going to get to the right conclusions. You'll get the wrong answers, essentially, about what kind of grid you should build going forward. We're talking about how do you make the good decisions for building a lot of infrastructure, for plowing hundreds of billions of dollars into something. Let's make sure that those are based on the right tools in order to make the right decisions.
What are the specific applications that utilities need these batteries for? So you have a few contracts with leading utilities. Your most recent one is with Georgia Power for a 1,500 megawatt hour project. And for context, that's more duration than every battery project deployed in 2019 in the U.S. So why does Georgia Power need a battery for that duration? And what are utilities specifically requesting these batteries for? What do they want to replace? And what do their grid mixes look like that would require this kind of battery?
Yeah, so in one word, reliability. That's really what it comes down to. And in two words, decarbonized reliability. And, that there are many challenges that the electric system faces today. And one of those challenges is meeting demand growth, frankly. Right now, we see a massive push to electrification for all sorts of things, but primarily for transportation, of course, the rise of electric vehicles, as well as the rise of electrification of industrial processes, because electricity is such a low-cost source of power these days. And so that is driving a lot of demand, frankly, for just growth in general. I was just at a conference not very long ago. A lot of it was on AI. And one of the main limiters for the growth of the AI industry today is electricity. They just can't get enough. And when you're limited by electricity, you're growing fast. It's sort of shocking. The other is just overall system reliability. So even if we weren't growing very, very quickly in the electric system today, there is a big transition that's happening. And many assets that used to provide reliability have been retired. I'm referring to specifically coal. We've retired roughly 200 gigawatts of coal in the last 20-ish years or so. Most of that has been replaced by natural gas, but that is not growing as fast as it probably needs to sort of maintain the reliability levels of the grid overall. And you see this, on the planning radars of all the organized markets that are out there, right? MISO, which is the main independent system operator in the Midwest organized wholesale market, they have a whole work stream called the reliability imperative because they see this coming. And, with increasingly volatile and frequent weather events, with demand growth, with a shift to weather-based power generation, keeping the lights on is a challenge. And keeping the lights on while we drive that energy transition is an increasing challenge. So for Georgia Power, for Xcel Energy, which is another of our big utility partners that we're working with, that's the primary reason. In their system, how do they maintain reliability? And increasingly, how do they maintain decarbonized reliability? And so it's all of these things that are now driving these utilities to take some risk to look at new types of things, whereas previously they just didn't have to, or it was too risky for them to go do that. So the paradigm has shifted, and I would say permanently so.
So the Department of Energy is getting really serious about supporting frontier technologies like long-duration storage, hydrogen, carbon removal, and they put together these commercial pathways called liftoff reports that try to bring together talent inside national labs, forge manufacturing partnerships, assist in commercial deployment as part of this strategy. And they say, the DOE says we need 460 gigawatts of long-duration storage capacity to keep us on a net zero emissions pathway, which is a lot of storage. I mean, how much of a lift is that in the coming decades? And then what do you make of this government strategy?
Yeah. So first of all, I mean, the work by the DOE on this topic and broadly, I would say recently has been fantastic. The term long duration storage is one that's pretty broadly used. So we do use that. We collectively use that term to refer to everything from 6 hours of lithium ion to seasonal hydrogen storage. So I like to parse that a little bit and say that what Form is doing is what we refer to as multi-day storage, specifically within that sort of long duration big bucket. So the way that we see the landscape playing out is you'll need several different distinct types of long duration storage, almost certainly, and we're really targeting that multi-day storage. But yes, it is a very large market, broadly speaking. And the work to just even lay that out is important. There's an industry group also called the Long Duration Energy Storage Council, the LDS Council, and they're doing important work to sort of clarify these issues as well, and we're an active part of that. So that's just laying it out and sort of again back to the analytics. It's really important to be able to clearly establish the case for these technologies as differentiated and providing high value into the system. Anything at that scale that you're talking about, it doesn't matter what duration you're picking there for long duration. At that scale, hundreds of gigawatts, there's no realm in which having something that large show up on the grid does not involve the government in some way. That sort of doesn't. That's just not how things work. So this is infrastructure after all, and the government is heavily involved in infrastructure. It's probably the right place for it to be involved. Frankly, is in infrastructure, shared, commonly beneficial infrastructure, whether it's highways or it's military or it's power infrastructure. And so seeing what the government is doing today, the Department of Energy Inflation Reduction Act today is doing on the electric system is incredibly important, and it's certainly beneficial for Form, but I would say even more so for the entire industry, the power industry overall. And so there's a lot of ways, of course, in which that support is being brought to bear in the industry, and these liftoff reports and focus on the long duration energy storage component of that is important, but it is quite broad based, and there's a lot of things that are happening.
And then the Bipartisan Infrastructure Act and the Inflation Reduction Act include incentives for manufacturers and the build out of this infrastructure. What is most important for you under those laws, and what do you make of the effectiveness of these laws in establishing a real green industrial strategy in the United States, which is such a core piece of the Biden administration's clean energy policy?
The Inflation Reduction Act, is probably best understood as a industrial policy, frankly, and that is distilled down to a statement: we're going to make stuff in the United States again, especially for this energy transition that's already well underway and is global, and so what we see is really our customers moving even more quickly than what they had been planning before because of that bill and because of the support to manufacture things in the United States. So it is quite meaningful for us, I would say, for the broad-based support for the build-out of manufacturing capacity in the United States and for the power infrastructure to move forward quickly, to update all of it, essentially. And the scale is pretty staggering. You mentioned the stats for long-duration energy storage, hundreds of gigawatts. That's, hundreds of billions of dollars for just, one type of energy storage in the system. And that's setting aside the generation side of it, right? The power transmission side of it, the electrification on the industrial side of it. So there's, it's really just a small fraction, frankly, of the total investment. It will be in the trillions of dollars over the next couple of decades. And that's just a massive, massive wave that Form hopefully will ride for quite some time.
In the coming years, do you think you'll feel more like a traditional steel industry executive or like a cutting edge climate tech executive, or like where do you think you'll categorize yourself?
Well, I hope we come up with a new category, frankly, and that the old paradigms are useful to learn from and to understand what's possible, but hopefully we also chart a new path, and we can sort of maybe break down some of the silos of thinking that have gone into drawing these divisions between clean tech and old tech, or old industrial processes versus new ones, and some it can be a little confusing and mind bending sometimes to sort of build these new categories. But what we have found is alliances with folks who maybe you wouldn't consider, take Georgia Power, for example. They are not what most would have considered to be a very forward-leaning utility, and here they are, our one of our major partners, leaning into the technology and to the energy transition, broadly speaking. And same thing is true of the state of West Virginia. And I think part of it is understanding that energy is and always has been and always will be important for the activities that we as humans like to do and need to do. And so as long as we're sort of oriented around energy as the unifier there, then you can see these new technologies playing a really important role and bringing the communities along with it to sort of deliver on what's possible for all these folks. And I sometimes I try and get baited into a old economy, coal economy type. Isn't that so bad? And I try and really resist that because I think take the state of West Virginia. It did everything that was asked of it, right? In terms of delivering the power that built the steel factories that delivered the tanks, and so on. That is the Secretary of Economic Development for West Virginia likes to sort of cite that litany, and it's true. And what we need to do is make sure that we're asking West Virginia to deliver again on the next wave of energy, and to be there and to be a part of it. And so I hope that we do create a new category, and we create it with folks that we're there with.
Here's to new industrial categories. Mateo Jaramillo, the co-founder and CEO of Form Energy, thank you so much.
Thanks very much, Stephen. Always great to talk to you.
The Carbon Copy is a co-production of Postscript Media and Canary Media. This episode was produced and written by me. Sean Marquand is our engineer. Roy Campanella mixed the show. Original music came from Echo Finch and Blue Dot Sessions. Postscript Media is supported by Prelude Ventures. Prelude is a venture capital firm that partners with entrepreneurs across advanced energy, food and agriculture, transportation, logistics, advanced materials and manufacturing, and advanced computing. And you can help us out by sending a link to a colleague who you think would like the show, and by giving us a rating on Apple or Spotify, and send your thoughts on social media. I'm Stephen Lacey. This is The Carbon Copy. We'll catch you next time. The U.S. storage market is expanding quickly. Over the last 5 years, grid-scale storage has grown by almost 1,800%, according to Wood Mackenzie, and battery electric vehicle sales are booming, with 55% growth in 2022. But there's a catch. Those batteries are overwhelmingly made overseas.
It's great that we're investing a lot of money in EVs. That's fantastic. But I saw the evolution of technology coming to lithium batteries, green technology, EVs, and it was very clear that all that technology was somewhere else.
Lindsay Gorel is the founder and CEO of Core Power, an American maker of battery cells. Lindsay comes from the mining sector, so he knows the ins and outs of supply chains.
That background for me has really made me understand of how do you get to the final thing, which is basically sustainability inside the United States.
Core Power is constructing a 15 gigawatt-hour battery cell facility in Arizona, which will serve a wide variety of battery markets.
We're one of the only companies in the world that produces cells, fully integrated 4-level software platform that is all integrated into our own controls to produce a top-tier energy storage solution. So by having all that technology, we can bring from the cells to the finished product to the market.
I talked with Lindsay about the urgency of building up America's battery supply chain. The numbers are pretty stark in terms of dominance of supply chain outside of the United States. China accounts for, I think, around 85% of American lithium-ion battery imports. What's the current state of U.S. reliance on other countries for battery production?
You hit it on the head. I mean, United States reliability on overseas supply chain and clean energy technology is well documented. But what we really should be talking about is what are we doing to remedy that over-reliance? Because we are there's over-reliance right now across the board. We saw projects and supply chains took major steps back, during COVID, right? And also the industry is just now getting back to where it was pre-pandemic. We're wrapping up production in the United States, but also taking steps to ensure that new progress isn't slowed by geopolitical shifts or other unforeseen issues like a global pandemic. So the biggest issue is onshoring the supply chain, right? That's the biggest hurdle to get past. One of the things we've done, and which is now public, is we've established sourcing partnerships like with companies like Novonix. So Novonix is a U.S. company and helped them augment and onshore the supply chain for battery cell anode technology. One of the things you got to do is you got to have a cell. The cell manufacturing has to be in the United States to develop a supply chain because you have to have a customer. So we were able to basically support Novonix to build the anode plant in Tennessee that provides our supply chain to us, And another thing is the real work toward establishing a proper supply chain and workforce is ramping up production in North America. So we're going to be operational in 2025, and we need a robust workforce. So not just the supply chain side of it, but you need a workforce. And we'll generate thousands of jobs in the Phoenix area. And we've been working with local colleges to create the next generation of clean energy workforce over the last 2 years.
So we've been in this acute period where everyone has seen things get messed up and it's exposed all sorts of vulnerabilities. Can you give some examples of how supply chain disruptions have been problematic, either across the economy or in energy specifically?
Yeah, I think we saw it across the economy, right? I mean, simply put, it creates kind of bottlenecks that constrain the entire domestic clean energy industry in our industry. If we want to deploy the amount of clean energy necessary to reach decarbonization goals, we really need to reevaluate and remedy the reliance on imported clean energy technology components. So to do that is you have to onshore. So onshoring the supply chain will unleash the potential of domestic manufacturing. Having done this, geopolitical shifts, relationships between the U.S. government and other countries have less impact on domestic companies' ability to source the material needed for things like anodes, cathodes, insulate them from spikes in supply chain demands, pricing, shipping costs, et cetera, which invariably will create a supply chain to the consumer at a reasonable price. It doesn't fluctuate by pricing pressures from outside sources, et cetera. Freight is one of the big ones that happened, obviously, through the pandemic, Think about it this way. Simple put, if the EU puts plans into motion to phase out all fossil fuel vehicles, all OEM and EV manufacturers are suddenly competing with the same supply of materials. We are competing with the entire world. So unless you can localize your supply chain, or at least localize meaning maybe United States, North America, or somewhere close by, you have the whole world will affect you. I always say, as a hockey player, the United States is talking about winning the Stanley Cup, right? But we are still just learning how to skate right, in this industry. So if you want to hit climate goals, you have to make your own batteries.
So when do we get the stick handling skills then?
It's a focused 5-year goal. If we focus 5 years on the developing a supply chain, looking at cell technology, looking at building cells, we really can support ourselves. It's all here, right?
Again, Lindsay Gorel is the founder and CEO of Core Power. To learn more about Core Power's investments in American industry and workers, go to corepower.com/carbon copy. That's KORE power.com/carbon copy.